Hey guys, this is Dr. Hub. Today we'll look at the respiratory chain as well as the ETC. ETC stands for the electron transport chain. So first we'll be looking at the RC. So let's look at from where the food begins. So in respiratory chain, the food, it goes down as the fatty acids as well as the glycerol. Next is the carbohydrates. The carbohydrates, if you see, it moves down as there is glucose, there is fructose, and this enters. Next is there is also presence of protein. They go down as the amino acids, and all this is a part of the digestion as well as the absorption. So we are seeing fatty acids, glycerol, glucose, fructose, and amino acids. So all this will enter the mitochondria. So then let's draw the mitochondria. So all this enters the mitochondria as the acetyl CoA and enters the citric cycle, citric acid cycle. So we're writing it as CAC, and it leads to 2H and it enters the respiratory chain. So in the respiratory chain there are some equations, that is a 2H. It leads to formation of ATP, and then there's addition of oxygen leading to H2O. Then the respiratory chain, it also gives rise to the ADP. So in the process of the fatty acids going on to become the acetyl CoA, there is also a beta oxidation taking place, which leads to the 2H. So to make it clear, this is the mitochondria, and there are also contribution of the 2H is by the extra mitochondrial sources of reducing equivalence. Extra mitochondrial sources, and this is of the reducing equivalence. Next we'll move on to the ETC. ETC stands for the electron transport chain. So this ETC is nothing but the electron transport chain. So let's look at the structures. So we have the mitochondrial membrane. Let's draw the mitochondrial membrane. Okay, we consider this as the inner mitochondrial membrane. We are writing it as IMM. Then this will be the mitochondrial matrix. And lastly, inside we are going to have the intermembrane space. This is the intermembrane space. Now let's look at it. So first is there is a complex one. This is complex one. Next comes the C2. Then comes the presence of C3. Next there is the C4 as well as then comes the C5. So breaking down the complex 1, what do we have here? There is conversion of NADH to NAD plus, and in 2 there is FADH 2 to FAD. Next in C3 there is the presence of COQ as well as there is a cytochrome C between the C and 4. Cytochrome C. So we are writing it as CCC. So here what's happening is there is also the presence of half oxygen along with 2H will lead to the H2O. And lastly, in the complex 5, it is going to be the presence of the ADP plus the PI. So AD plus PI will give rise to, it is giving rise to ATP. It gives rise to the ATP. So let's look at some inhibition which is taking place. So the complex 1 will be inhibited by the rotenone. Okay, this is known as rotenone. This is the inhibition. And what is happening here is the complex 1, it gives rise to the H plus. This gives rise to H plus. This H plus is carried on to the complex 5. In complex 5, this H plus it goes to. Then next we look at the complex 2. Complex 2, here there is the succinate dehydrogenase, presence of the succinate dehydrogenase. Then when you are looking at C3, the inhibition here is by the antimycin. The inhibition is by antimycin, and next there is the presence of H plus. Again the H plus it adds on and then it goes to the complex 5. Then when you are looking at the complex 4, the complex 4, here the inhibition is by the three things, the cyanide, there is also the CO as well as presence of the azide. So this is the inhibition. Next one, complex 4, there it goes to, complex 4 is nothing but the H plus. This goes and it again gives the H plus to the C5, that is a complex 5. The another thing you're missing is there is also the presence of, there is a 2,4-dinitrophenol aspirin overdose. 2,4-dinitrophenol OD, we are writing it as overdose. So this can contribute to the NADH. So this is the about the membrane. So then we in complex 5, what is the inhibition? The complex 5, the inhibition is brought by, there is, let's extend it and write it down. The inhibition here is brought by the oligomycin. There is oligomycin. So in complex 1 it was rotenol. We are just talking about the inhibitors. Complex 2 it was, in complex 2 we had the presence of succinate dehydrogenase. Then in antimycin it is inhibiting complex 3. Cyanide, CO and azide, it is phosphor, and 5 is oligomycin.